Hey there guys, this is Mr. Boyd. Today we want to look at a lesson on graphing quadratic equations or quadratic functions. So to begin with, we want to look at the three different forms of a quadratic function. First we have standard form, which is y equals ax squared plus bx plus c. This is the form we've seen most common here lately. Next we have vertex form, which looks a lot like complete the square. And in fact, that's how you get vertex form, is by completing the square. And then there's intercept form, or sometimes you'll even hear this called factored form. And that looks like a quadratic equation that's been factored. All right, standard form is y equals ax squared plus bx plus c. And the graph of a quadratic function is a parabola. A parabola can open either up or down. If the parabola opens up, then a, this term in front of the x squared, is positive, and the vertex is the lowest point on the graph. The vertex is also called a minimum in this case. If the parabola opens down, then a is negative, and the vertex is the highest point in the graph, and this vertex is called a maximum. If the parabola opened left or right, it would not be a function at all, as it would violate the vertical line test, which says that if a vertical line touches the graph in more than one spot, it's not a function. All right, now let's look at the line of symmetry. Parabolas have a symmetry to them, which means one half is a reflection of the other half. We call this line of reflection the line of symmetry. The line of symmetry always goes through the vertex. So if we graph one side of a parabola, we could fold or reflect it over the line of symmetry to graph the other side. There are three steps to graphing a parabola in standard form. Step 1, find the line of symmetry. For this, we're going to use the equation x equals negative b divided by 2a, or the opposite of b divided by 2 times a. Next, we'll find the vertex. We'll do this by plugging in the x value that we just found when we found the line of symmetry. We'll plug that into the original equation and obtain the y value by solving the equation. Next, we'll find two other points and reflect them across the line of symmetry. Then connect the 5 points with a smooth curve. To do this, you can choose x values that are close to the line of symmetry and plug them into the equation to find the corresponding y values. One of those values, and one of the most easiest ones to find, is by finding the y-intercept. So it's good to have 0 as one of those. Now, if your vertex is on the y-axis, you can't use the y-intercept as one of your additional points. So let's try one. So to begin with, we're going to find the line of symmetry. Here I've plugged in the negative 4, and the opposite of negative 4 would be positive 4. I've plugged in the 2 for the a, and here we see 4 divided by 2 times 2 is just 1. So this tells me that the axis of symmetry, or the line of symmetry, is x equals 1. It's a vertical line that goes through the point x equals 1. Moving on to step 2, we need to find the vertex. Since the x value of the vertex is given by the line of symmetry, we need to plug x equals 1 in to find the y value of the vertex. So here I've plugged in 1 and worked it out, and I find that y equals negative 3. So my vertex is at 1, -3. Okay, for step 3, we're going to find two other points and reflect them across the line of symmetry and then draw our curve. So I've chosen the x values 2 and 3 because my line of symmetry is x equals 1. So here I've plugged in 2, solved the equation, and found that y equals -1. So now I have the point 2, -1, and I'll plot that on my graph. Next I'll plug in 3. So here I've plugged in 3, solved the equation, and found that the answer is 5. So y equals 5 when x equals 3. So now I have the point 3, 5, and I'll plot that point on my graph. Next, I'll reflect these 2 points across the line of symmetry. That gives me 2 more points for a total of 5 points. Now I can draw my curve through the 5 points, and I have my parabola. Thanks guys for watching. This concludes the video on graphing a quadratic function in standard form. Stay tuned for another video on graphing a quadratic function in vertex form, and then there will be a third video as well on intercept form. Remember always to subscribe to my YouTube channel for all the algebra videos.